Okay, what I wanted to do is go through the Module 1 test review. So we have a test on Monday and Tuesday, so I want to make sure that you are set for it. So going through the test review, and I would hope that you do this too. I'll be sending out an email later today about this, but just kind of wanted to walk through the questions to make sure that you could handle these and to give you the answers right away so that you can see them. So of course this isn't due. We'll give it a second. So now it's up. So what we're going to do is we're going to start this. So let me move this around. If it lets me, come on, move it around, please. It's not letting me move it. That stinks. So let me see if I can get in there. Start the assignment somewhere. Okay. Okay. So now we're going to move. Great. So now we're going to move through this, and we're going to kind of get through the problems. But it says which best describes. I'm going to go out a little bit. So which best describes the function shown? So notice that we have a function that is constant up to this point, but then it stops, so it's not equal to anything at the y-axis, which happens to be 5, so or 0, 5. And then it continues on from there. So it's definitely not continuous, so that eliminates A and B. It's not discontinuous. It could be discontinuous, so it's not discrete. So that's what's important, is it's not discrete. So we know it's not discrete because of that. So it's can't be discrete and discontinuous. It's not discrete and continuous. It can't be, well, actually, maybe it is. So we'll see what that is. So it's definitely not discrete, and it's not continuous in that particular case. I guess I have to think about that a little bit. But we'll kind of come back and see which one it is. So definitely not continuous, definitely not discrete. So it's not discrete and continuous. I'm not exactly sure what they're saying there, but my guess is that's probably not true, because they're saying not discrete and not continuous would mean that that would be true. So anyway, so discontinuous got to be one of these two. Notice that the domain is where x is not equal to 0, so x cannot be equal to 0 at that point, not y equal to 0, so it has to be D. And then I think it is not discrete, and it is discontinuous. I think that's what it's saying. Discontinuous means it's neither. So I won't put that in there. I'm going to give you a problem that's either going to be continuous or discrete when you're working with it, so it'll be a little bit more clear. Okay, problem number 2. So select all the relations that are linear, not linear, because that's not to the first power, that's to the 1/2 power. Both of those are to the first power. Okay, both of the variables here are to the first power, so it's D, even though they're not combined together. Y is to the first power. X is to the first power, however, it's inside the absolute value, and we know the absolute value looks like a V, either going up or going down. Y equals -3 is a horizontal line, so that's got to be a linear function. And then we have these two multiplied together, so those are not linear functions. Okay. Oh, I can actually go up here. Okay, so now the table shows a pair of functions. The pattern continues. The x-intercept will eventually be, so notice this is going down by 2, so that's going to be -4, then -2, then 0. And that means 8, 9, 10. So I believe the x-intercept will be, and I'm assuming in this particular case, what's happening there. So oh wait, so never mind. It goes. I'm thinking. No, I'm thinking correctly. So -4, negative value over there, and the y-intercept is going to be. So the y-intercept is when x is true. So that one's going to be at 11. So when x is 0, y is 11. So -4, -2, 0, 9, 10, 11. And then on the x-intercept, that is when y is 0. So notice y is going to 0 to the left. So it'd be 3, 2, 1, 0. So it'd be 4 steps away. So that would be -16, -18, -20, -22. That should be -22. I won't make it as confusing as that, but I understand what they're asking in this one. So question number 4. So this first one, you can see there, so it looks like it has point symmetry because if I put a point right here, I can see that if it flips over and goes to the other side, it's going to be symmetrical. So I think this one's point symmetry. This one I think is no symmetry, neither, because there's no even curves on both sides. This one I would be line symmetry because of this line, and not point symmetry because point would mean that if I put a point here, this would actually flip over and go down. So I think this is line. Okay. And then on number 5, so the value for the relative minimum in the function, so notice this one here is x plus 4 squared minus 3. So that's going to be a parabola that is going up. So the value for the relative min in this particular case for x, here's a parabola that's also going up. We'd have to graph both of those to kind of see what they generally look like. So x plus 4 squared. So I thought that was going to be a little easier, so that's okay. X plus 4 squared minus 3. So that tells me that we go down 3 and we go to negative 4. So that means my parabola is going to be over there, and then we go up 1. There we go. And then we go over 2 and up 4. 1, 2, 3, 4. It's going to be looking the same on the other side, so it's going to look something like that. Okay, so now if we graph the other one, which I think was 2x squared minus 7, maybe? Yeah. And actually, we could just look at this. So just looking at this one now, I can see it. So 2x squared minus 7. Notice there is no x. It does not move along the x-axis in any different direction. So it just moves down 7, but it goes up twice as fast. So it would be, instead of here, it would be here. So it's just going to go up. It's going to go up a little bit faster. So which one has the, and I think they're asking actually for the absolute minimum because these are actually absolute minimums, not relative minimums, but I'll be clear in my wording. So I think the 2x squared has a higher one or has a lower one. So let's see, the value for the relative min in the function is, so this function is greater than the value of x in the relative minimum for the other one. Oh, it says the value of x for the relative minimum. Let's take a look at that. So the value of x, so the value of x here is 0. The value of x here is 4. So the value of x in this one is less than the value of x in this one. So this kind of shows me that I always tell you guys to read your questions carefully. Notice that I went back and kind of reread the question just to make sure it was saying the value of x, not the value of y. Okay, number 6. So which function is true where x goes from negative, as x goes to negative infinity, y goes up? So as x goes left, y goes up. So definitely not b. This one is a parabola that faces up. That does not. This does. Let's see if I'm missing any others. Oh, I forgot to do this one. This one is an absolute value that faces up unless there's a negative in front. And since there's no negative in front, that goes up. So it's got to be that one too. Okay, we're going to do one more and then go to the next video. Okay, in this particular case, we have a graph. Which key figures of the graph can we figure out based on that? As f of x has an x-intercept somewhere between 0 and 1. That's correct. As x goes to negative infinity, y goes to positive infinity. And as x goes to positive infinity, y goes to negative infinity. That's not true because it does not go down. Okay, f of x has a minimum value of negative 1. So that would be the y value. So no, it does not have a minimum value of negative 1. F of x has a y-intercept, though, at 0, negative 2. 0, -2. It looks like there is one there. F of x has a minimum value of -3. 1, 2, 3. That is true. And that's it. So it should be, I believe, A, D, and E. And I'll stop here, and we'll do the rest of the problems on the next video.